For this problem, first we want to do some calculations for the nitrite ion, and then we want to make two drawings, one with formal charges on the atoms and the other with oxidation states. Electrons required is going to be the number of atoms, which is 3, times 8 electrons per atom. This is the number of electrons needed if no bonds are formed. Valence electrons is the number of electrons we actually have to work with. Nitrogen has 5 valence electrons. We have 2 oxygens, each with 6 valence electrons. And our ion has a -1 charge, so we add 1 more electron. This gives us 18 valence electrons. The number of shared pairs will be our electrons required minus our valence electrons divided by 2. This will give us 3 bonds. Our lone pairs will be our valence electrons minus the ones that are involved in bonds, which would be, of course, 6 electrons, or 2 times 3 bonds. And this will give us 12 electrons involved in bonds, or 6 lone pairs. Now it's time to draw the nitrite ion. Nitrogen goes in the middle and oxygens on either side. We know that we have 3 bonds, so it doesn't matter if I put the single bond on the left side or the right side. I just need to put 3 bonds in this compound. Each atom needs 8 total electrons around it. Bonds hold 2 electrons. So the oxygen on the left side will need 3 lone pairs, nitrogen will need 1 lone pair, and the oxygen on the right side will need 2 lone pairs. As you can see, the oxygen on the left believes it has access to 8 electrons. The nitrogen in the middle has access to 8 electrons, and the oxygen on the right side has access to 8 electrons. And the total number of electrons in this drawing is 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. So that is our Lewis structure. So first, I'm going to draw the structure with formal charge. In formal charge, we divide the bonds evenly. So what we see in the circle is that oxygen on the left has 7 electrons in the circle, nitrogen has 5, and this other oxygen on the right has 6. But let's think about how many electrons oxygen is used to having around it in its valence diagram. It's in group 6. So this oxygen on the left feels as if it has a -1 formal charge. Nitrogen is accustomed to 5 valence electrons, and it has 5 electrons around it, so its formal charge is 0. And the oxygen on the right has 6 electrons around it, and it is used to having 6 valence electrons around it, so its formal charge is also 0. Notice the sum of the formal charges adds up to the charge on the nitrite ion, which is -1. Now let's try the same structure again, but with oxidation states. In oxidation states, the bond between 2 atoms has the electrons going to the more electronegative atom. So we know that oxygen is more electronegative than nitrogen. So the 2 oxygens are going to get all of the bonding electrons. The oxygen on the left side has 8 electrons in its circle. Poor nitrogen has only 2, and the oxygen on the right side has 8. As before, both oxygens are accustomed to 6 valence electrons. So if they feel that there are 8 around them, this gives each oxygen an oxidation state of -2. As before, nitrogen is accustomed to 5 valence electrons, but it has 2 in its circle. So 5 minus 2 gives it an oxidation state of +3. Once again, notice the sum of the oxidation states, -2, +3, and -4, add up to the charge on the nitrite ion.